Hi students, and welcome to today's lesson. I'm Mr. Hunter. Today we will explore the question, what factors determine the appearance of stars? Are you ready? Grab your pencil and your science journal and let's get started. Wow, look at this photograph. This photograph was taken by the Hubble Space Telescope while it was in orbit high above Earth. Look at all those stars. What do you notice in this photograph? I see many stars that appear different colors, white, orange, and even blue. Some stars even seem brighter and larger than others. I wonder, what might cause these stars to appear different? Well, stars that are far away look smaller, right? So that means stars that are closer to us appear larger. Also, stars can be different in actual size and brightness. In our last lesson, we identified the relationship between distance and the apparent size of stars. Today, we will explore the apparent brightness of stars. This is a photograph of the night sky. Which star appears to be the brightest from Earth? Did you say this star is the brightest? If so, you're right. This star is Sirius, the brightest star in the night sky. But can you think of a star that appears even brighter? Here's a hint. This star appears in the daytime sky. The sun! The sun is so bright that we can't see any other stars during the daytime. Why do you think the sun appears to be so much brighter than other stars? Well, the sun isn't actually the brightest star in the sky. We learned that Betelgeuse is much brighter than the sun. But the sun is so much closer to Earth than other stars that it appears to be the brightest. I think a model might help us understand the relationship between distance and brightness. What materials could we use to model the brightness of stars? We will need multiple light sources for our model. What can we use? I know, we can use 2 LED candles to model 2 stars that are the same brightness level. And we can use the lantern from our space view model to model a star that is much brighter. We can move the light sources closer to us or farther away from us and observe how distance affects their apparent brightness. But wait, stars are millions of miles apart, and we're in a pretty small space. It might be difficult for us to see which light source appears brighter. How could we compare brightness in a measurable way within our small scale? I know, we can use a Myers light device. This device can be used to observe apparent brightness. What do you notice about the Myers device? Hey, I noticed there are 2 sides on the device. Do you notice that too? When we hold the device near a light source, the side of the device facing the light source glows, while the other side does not. So how do you think we could use this device to evaluate the brightness of multiple light sources? Well, the device has 2 sides, so we can compare 2 light sources by placing one on each side of the device. The side of the device next to the brighter light source will glow more brightly, while the side next to the dimmer light source will not glow as brightly. If the light sources are equally bright, both sides of the device will look the same. The full name of the device is the Myers Light Intensity Comparer because it can be used to compare the brightness of light sources. Let's use the device to conduct a fair test to see how distance affects the apparent brightness of a light source. Let's set up an investigation using the FAIR test criteria. Remember, we are investigating the question, why is the sun the brightest star seen from Earth? We need to consider the actual brightness of the light sources as well as the distance between the light sources and the device. To start, Let's use the Myers Light Intensity Comparer to compare two identical light sources like these LED candles. We can only change one variable at a time, so which variable should we change? Let's change the distance between the lights and the device. We'll keep all the other variables constant and collect data in the form of observations we make about the brightness of each half of the device. We won't conduct multiple trials, but I think we've met enough of our fair test criteria to move forward with the investigation. So, how do the identical light sources compare? Look at this. The two halves of the device glow equally bright when the LED candles are the same distance apart. What do you notice when we move the LED candle on the left farther away? The left-hand side of the device dims, right? What about if we move the candle on the right farther away? Did you notice the right side dims? That's right. I noticed that as the distance from a light source increases, the apparent brightness of that light source decreases. Do you agree? How could we model why a very bright star like Betelgeuse appears much dimmer than the sun? For this model, we would need to use two different light sources. We need a larger and brighter light to represent Betelgeuse. So let's use our lantern. And let's use our LED candle to represent the smaller, dimmer sun. Earth is much closer to the sun than it is to Betelgeuse. So we should hold the device closer to the LED candle. What do you think we will see when we conduct this test? Let's try it out. Oh wow! When we move the Myers device very close to the LED candle, the half of the device closer to the LED candle glows brighter, even though the lantern is actually brighter. Because the lantern is so far away from the device, the lantern appears to be dimmer than the LED candle. That test explains why even a very bright star can appear dim if it is very far away. Remember this photograph from the beginning of our lesson? How can we explain why some of the stars appear brighter than others? Well, some stars are actually larger and brighter than others. And some stars appear brighter because they are much closer to us. So, stars vary in their actual brightness, and their distance from Earth can affect their apparent brightness. I wonder, how could we draw a model to demonstrate the relationship between a star's apparent brightness and the distance between the star and the observer? Well, we would need two stars at different distances. We would also need something to represent an observer. What else would you add? Think about how you can show light rays from the stars reaching the observer, and how you can show that one star is brighter than the other. One of your tasks after this lesson will be to draw a ray diagram to show the different apparent brightness of two stars. But before you draw your ray diagram, let's think about some of the limitations of this type of model. What are the limitations of a ray diagram model? I can think of one. The distance in the diagrams will not be realistic because stars are very far away, and not all stars have the same size or brightness. We know Betelgeuse is actually much larger and brighter than the sun, but that difference will be hard to show in our model. We've learned a lot about stars today. Let's update our anchor chart. Wow, we've added information about gravity, the sun, and the moon. Let's look closer at the sun section of our anchor chart. Under the Earth perspective, let's add the sun appears larger and brighter than other stars. Great! And under the space perspective, we can add the sun is a star and it is much closer to Earth than other stars. Hey, All this talk about stars is making me think it's time to add a section about stars to our anchor chart. I think we need to investigate stars a little more before we can add knowledge about the Earth perspective, don't you? So let's focus on our view of stars from the space perspective. We can add most stars are very far away from Earth. And stars produce their own light, like the sun, right? One of your tasks after this lesson will be to update the anchor chart. I have a question for you. Since distance affects the apparent brightness of stars, how can we figure out how bright stars actually are? Well, scientists have a way, thanks to an astronomer named Henrietta Leavitt. Henrietta Leavitt was one of several women who was hired to analyze data about the stars at Harvard Observatory. She studied the Cepheid variable stars. These stars brighten and dim periodically. The time it takes to brighten, dim, and brighten again is called the period. Leavitt was the first to identify a relationship between the period and the brightness of the Cepheid variable star. How fascinating! The discovery allows astronomers to use the period of a star to determine how bright the star actually is. They can then compare the star's actual brightness to its apparent brightness. This comparison allows astronomers to figure out how close the star is to Earth. What factors determine the appearance of stars? We learned that stars are very far from Earth, and their distance from Earth makes them seem smaller and dimmer. All stars are much bigger than the moon, but they seem smaller than the moon because they are so far away from Earth. Although the sun is also much bigger than the moon, the sun seems to be about the same size as the moon because it's farther from us than the moon. However, since the sun is still much closer than other stars, it appears as the biggest star in the sky. Wow! Distance really makes a difference, right? If stars are so far away, they must be incredibly bright for us to see them all the way from Earth. We will continue exploring our observations of stars as we work to answer the question, how can we explain our observations of stars? Let's review your tasks for today. First, fill in the blanks to update the anchor chart. Second, draw a ray diagram to show differences in apparent brightness of stars.